Hi, welcome to 20MinGameDev. I am Gio, and in this video series we're going to make games, complete and playable games in 20 minutes. So how is it possible that we can make games in 20 minutes? Mostly we will be using a tool that I created specifically for this purpose. It's called Wait. It's free, it runs in your browser. If you're not familiar with it, maybe you want to watch a short introduction, 5 minutes. Otherwise, let's go ahead and let's make some games. This is what we're going to make in the next 20 minutes. I don't think it needs any introduction really, because you've played this game a million times already. There's a ball that bounces off a paddle, it bounces off all these bricks and it breaks them. As usual, let's start by navigating to clockworkchili.com/wait, and here I'm going to create a blank new project called Breakout. As usual, we start with a bunch of files and an empty scene. Now I'm going to click the orange icon at the top that says Repo Browser, that lets us browse some pre-made assets. And in this case, I'm going to select the bricks repository that contains some pre-made graphics. These objects here are just some graphics that do not contain any code. We are going to write all the code that we need for this game. Are we going to make it in 20 minutes? Well, let's find out. So we start by dragging the border into the scene. And let's see what the sprite looks like. The sprite is 608 by 920 big, it says here in its size property. And I want to go to the scene properties. In settings, I want to set that same value, 608 by 920, both for the min screen size and max screen size. As we've already discussed in other tutorials, this gives us a fixed resolution for our window, which means that when I run the game, it doesn't matter what the aspect ratio is on the device that's running the game. We always see the same area of the game that's contained within the border, maybe with some bars on the side, if that needs be. Okay, now we've got a border. Let's also add a paddle to the scene, and this paddle should move when the mouse moves. So I'm going to create a new script for that, and I'm going to go to the folder view, click new file, and create a new file called controls. It is a script, so it's a JavaScript file. And in here, I'm going to create a function called wait.app.onMouseMove. Now, this function is going to be executed every time I move the mouse anywhere on the screen, on the game area, I should say. But not just the mouse, even if it was running on a touchscreen device, this function would be called when your finger moves anywhere on the game area. And this function gets passed a data parameter that contains a screen position. That's what we want to use to control the position of the paddle. We only care about the x coordinate of that, because for y, we're just going to keep the paddle current y position. So _.paddle.getPosition.y. So _.paddle.setPosition x and y. If we run the game now, we can see that the paddle follows the mouse. However, it also goes over the borders and a bit beyond the game area. So we should set some limits for x specifically. The maximum it can move, really. Let's see, the paddle size is _paddle.getSprite.getSize, and the game area, the width, actually let's do paddle width is getSize.x, and screen width is wait.getScreenWidth. So the maximum, let's call it m, the paddle can move in this direction, for example, is going to be screen width over 2 minus paddle width over 2, so half the screen size minus half the paddle size, minus a little bit to take into account this blue bit of the border, which I'm guessing is about 32 pixels wide. And once we've got that, if x is greater than m, then x equals m. And conversely, if x is less than minus m, then x equals minus m. When I run the game now, oh, and also paddle width, I have misspelled it here, it should be a lowercase, so it should be an uppercase W. So when I run the game now, the paddle follows the mouse and it stays within the game area, which is what we wanted. Now let's add a ball here by going back into the repository and dragging a ball into the scene. Now this ball, initially, we want it to follow the paddle. So let's go into the properties of the ball and let's give it a custom property called stick to paddle. And this one, we set it to true. So in our, let's go back to the code editor. In our onMouse move function, when we set the paddle position, we also say if _ball.stick_to-paddle, then we also set the position of the ball. _ball.setPosition x, and let's say y plus 20. I'm not sure, that 20, maybe 25. Let's see what that looks like. Well, that looks wrong because it should have been minus 25 to move it up with respect to the paddle. So yes, that looks approximately correct. Okay, now when I click the mouse, so wait.app.onMouseDown, and again, this function is going to be called also when you touch your touchscreen device with your finger. So on tap. On mouse down, we don't really need this data object. What we want to do, if the ball stick to paddle property is true, then we launch the ball. So we set some velocity. Well, to do this, I would say at the top of this file, let's define wait.app.ball speed, a constant that we set to 500 units per second, for example. And once we've got that, we want to calculate a velocity vector to get the ball moving. This velocity vector, we want it to be 500 long. So let's see, this vector should be some random number on x. I'm doing random minus 0.5, which gives us a random number between minus 0.5 and plus 0.5, because math.random gives us a number between 0 and 1. So x is that, and y is minus 1, because this is a vector that points up. Okay, I take that and I also scale it using wait.vec2.scale. So I scale that vector by wait.app.ball speed. And finally, _.ball.setVelocity v. We also want to do _.ball.stick-to-paddle equals false. So this code is not executed again once we click again. So let's see now. I click and the ball goes. Of course, it doesn't bounce off anything. Now let's address this problem straight away by, I think it would be simple to, yes, it would be simple to just give some borders, some physics shapes, but simpler still, we can create some extra objects like this square here. I'm going to make it a rectangle. And it doesn't have to be precise, but I'm going to overlay it to the border. And this object, I go into the behaviors of the object, and I'm going to make it a physics object. That means it's going to be controlled by Wade's physics engine. My plan for this game is to use the built-in physics engine that comes with Wade, although this engine really is meant to simulate realistic physics. And in this particular game, we do not want realistic physics. We want almost realistic physics because the way the ball bounces off the bricks is pretty realistic. Also, the way the ball bounces off the borders is pretty realistic. but the way the ball bounces off the paddle is not realistic at all. So in this game, typically, if the ball hits the paddle on the left side, then it bounces left. If it hits it on the right side, then it bounces right, which is not how physics work in real life. But because this engine is very flexible, we can tell it that we want to override the way it behaves when the ball hits the paddle, and we keep its default behavior for all the other types of collisions. And now I'm going to show you exactly how to do that. Let's start by making this border a physics object. When I click add, it's going to ask me if I want to add weight physics to my project, and I say OK. Now this, I am happy with the default value of the physics object, which make it a static object, and the physics shape is just going to be the bounding box of this. So that's pretty much what I want. So I also want this to be invisible, but for now let's keep it visible, and let's duplicate it. So we have one on the right, and let's duplicate it again. So we have one on the top, and this one really needs resizing quite a lot, I would say. So something like that and like that. I could have rotated it as well. I wouldn't have changed anything. Now I've got these in place. I want them to let's see, I want them to be invisible. So let's go to the sprites and set them to visible false, all of them. So they're going to be in the scene, but we cannot see them. Now the ball itself needs to be a physics object as well. Let's go to its behaviors. Let's select physics object. And in this case, it's going to be a dynamic object that moves according to the rules of physics. And I want to edit its physics shapes as well, because by default it's going to be this bounding box, which is a square. I don't want that. I remove it and add a circle instead. And I size it appropriately. And click apply. Now this is a physics object that initially is going to fall down under the effect of gravity, as you can see. But we don't want gravity in this game, so I set gravity scale to 0. And finally, I think I want to make this one a physics object as well. The paddle should be a physics object that's static, because it doesn't move according to the rules of physics. It moves when we move the mouse. And I'm happy with the default physics shape, pretty much. I could adjust it, but it will do for now. So now I've got that. As you can see, I can launch the ball. It bounces off the borders, it bounces off the paddle. However, it will tend, because of floating point errors, it will tend to lose some momentum. It will tend to lose some energy. And we do not want that. We want the velocity of the ball to be constant all the time. So I'm selecting the ball, and I'm going into its onUpdate function. Here we get the current velocity of the ball, this.getVelocity, and actually we normalize this velocity vector. Now, can we always normalize a vector? Normalize means make it of length 1. Well, not always, because if the vector is length 0, normalizing involves dividing by its length, which is going to give us an error when the length is 0. But there is a handy function called normalize if possible that takes that case into account. So it doesn't normalize if the vector is 0. So once we've got a normalized vector, we scale it, wave.vec2scale v, by that same ball speed constant that we defined earlier. And we apply this new velocity. So this.setVelocity v. This will ensure that we do not lose any momentum. Is there something else that we want to do with the ball velocity? Yes, there is, because at the moment, the ball, let's see if I can demonstrate this very quickly. Let's see if I can hit it with the side of my paddle. No, I couldn't. But theoretically, we could give it a mostly horizontal velocity, which is also something that we do not want in this case. So let's do this. If weight.vec2.length v, so if the length of this vector v is greater than 0.1, for example, so if it is a non-zero vector, then we do this, but we also look at the y component of v, so or the x component really. If v dot x is the absolute value of it is greater than the absolute value of v dot y, okay, we set v dot x to be the absolute value of v dot y, okay, and if v dot x was greater than 0, then we multiply this by 1. Otherwise, we multiply this by -1. So this implies that the x part of the velocity is always going to be most the same as the y part of the velocity, in terms of absolute values anyway. So when I run this, we should never have any horizontal movement, even if I hit the ball with my paddle. Now, let's see if we can change this sort of realistic bouncing of the paddle behavior. We want it to always go left if the ball is left of the paddle. So let's select the paddle. Let's select, actually, let's select the ball. It's easier. Let's select the ball. Let's go to on collision. This function is called every time we have a collision with something. And if, so the data object that gets passed to this function, you can see here, contains an other object field that tells us what we are colliding with. So if data.otherObject is the paddle, okay, you can see here it says you can return true from this function to cancel the collision resolution. So we return true. That's telling the physics engine, if we are colliding with the paddle, don't do your normal collision thing. We are going to handle this collision in this case. And how do we handle it? Well, first of all, we see where we are. This dot get position. We see where the paddle is. Underscore dot paddle dot get position. And we look at the distance on the x-axis. So that will be pos.x minus paddle pos.x. And actually, if we want to normalize this value, so to speak, so it's always between -1 and 1, then all we have to do is divide by half the width of the paddle, which is get size, get sprite dot x over 2. Let's put some brackets for clarity. Okay, and once we've got that, we can define a new velocity vector, which is exactly this dx for the x component, and -1 on y. Again, we scale this vector using weight.vec2.scale, and we scale it by our ball speed constant, and this set velocity v. So now we will have non-realistic, and no, of course it's get sprite, get size. Sorry about that. Oh, and also we only want to do this if not this dot stick to paddle. Okay, let's have a look. Yes, that works. So we have non-realistic collisions with our paddle. So let's go ahead and add some bricks to complete this game. Let's go back to the repository and let's drag a brick into the scene. Now this, I'm going to position it here. And again, I want this to be a physics object. And again, I'm happy with the default values for this physics object. But what I want to do, I want to go into its on-collision behavior. And if data.otherObject is the ball, weight.removeSeeObject this. So we just delete the object if we collide with the ball. So now this is going to work, but we only have one brick. We want more than one. So I'm going to go to the onAddToScene function, which is executed when the object is added to the scene. And here, I would like to do this .toGrid75. This means create a grid of objects of the same type. However, this will clone the object several times, and each clone will have all the functions and all the properties of this same object, including this same onAddToScene function. So each clone will also try to clone itself when it's added to the scene. That will result in an infinite loop. To prevent that, we only call toGrid if this is the block blue object. You can see the name of the object is block blue. So if we are exactly that object, we do this. If we are a clone of that object, then we don't do that. So when I run the game, I've got lots of bricks, and I cannot destroy them. Let's have a look at why. Because on collision, I have misspelled remove scene object. So let's try that. And yes, that works. So it's a nice fun game. Of course, there is a lot more you could add to this. Power-ups, different types of bricks that you have to hit multiple times before the break. But in 20 minutes, that's all we could do. But I think we should be quite proud because we haven't used any pre-made code, really. We wrote all the code ourselves, so that's quite an achievement. I hope you enjoyed making this game in 20 minutes. Thanks for watching. I hope to see you soon again for the next episode.